So hello, hello and welcome to our couch lessons. I'm very happy that so many people from all over the world are joining us again, and my name is Jeanette. I work for the Goethe-Institut in Munich, and maybe not everyone is familiar with the Goethe-Institut so far, so I will tell you just 2 sentences about it. The Goethe-Institut is the worldwide active cultural institute of the Federal Republic of Germany, and we promote the study of the German language abroad, and we encourage international cultural exchange. We want to deal with the topic of AI because we think that it has and it will have a huge impact on our society at different levels and in various fields. AI will contribute to a new revolution in human history. And that is what you can read over and over again. With it, writes the journalist André Cryer, for example, a mechanic mental power is created which, similar to the mechanic physical power in the then emerging industrial age, will give human history a new direction. And that's why we have to discuss it, whether we like it or not. And with the project Generation A as algorithm, the Goethe-Institut wants to present the technical developments in the field of artificial intelligence and at the same time reflect on them critically. A dialogue between different disciplines and backgrounds is really important for this, for example, with artists and their creative approaches to AI. We believe that the Goethe-Institut can establish such a dialogue. And the couch lessons, a format of the project Generation A, are a very good example for it. Every week, always on Wednesday, we invite AI experts from all over the world to discuss with us the risks, the challenges, but also the opportunities presented by the developments in the field of artificial intelligence. And with the couch lessons sponsored by the Federal Foreign Office, we want to sensitize our listeners to the technical developments in the field of AI. We want to encourage them to engage in discussions outside the technology-savvy community, and we want to question what AI is and what it could and should decide. We also want to ask if there is a way, maybe a European way, beyond surveillance and commerce, because a lot of developments in the field of AI are economy-driven so far. So it's all about power and money, or isn't it? Let's find some answers. I hope you have made yourself comfortable already, maybe on the couch, maybe with a cold drink in your hand, and that you will spend a pleasant hour with us. Hopefully you enjoyed the music we played at the beginning as well. It was the Cold song from the album Hello World. And Hello World was the first multi-artist music album composed with artificial intelligence. Its goal was to show that AI can be used to create new compelling music, generating fresh music material of all sorts, like melodies, harmonies, and rhythms. So can AI be creative? This is the question we want to deal with during our couch lesson of today. And as always, I have prepared a little poll for you, this time with 2 questions. Let me share this with you. Wait a sec. So do you think that machines can become creative? And is there a difference between a creative machine and a creative human? And as long as we wait for the answers, I would like to inform you briefly about some guidelines of our couch lessons. First, the invited experts will give an input, each about 10 minutes long. And after that, we will open the discussion. For you, I assume that it will take 45 minutes at all until we can discuss with you. Therefore, it is possible that we extend the lesson until 6:15 p.m. and I hope that's okay for you. You can always ask questions or contribute your opinions into our chat, and I will go through the chat and pick out some questions that we will discuss later. After the inputs, I will ask different persons to contribute their questions or thoughts personally, but if I don't ask you, please turn off your microphone. I also want you to know that the entire event is recorded, but we will just record the persons that are speaking. You can always turn off your video, although we would invite you to switch it on, because then we can see all the participants from all over the world. So let's have a look at the results of our little poll. So yeah, most of you think that machines can become creative, and still you think there is a difference between a creative machine and a creative human. So that's the thing we want to talk with our three guests. And I hand over to my co-host and the moderator of this lesson, Martin Törnqvist from Sweden. And thank you for listening.
Thank you, Jeanette. Hello, everybody. As Jeanette said, my name is Martin Törnqvist, and I'm a curator and context maker based in Malmö, Sweden. Again, very welcome to all of you. Today we have three speakers joining us from London and Catskill in upstate New York. We have the professor of mathematics, Marcus de Sotoy, a designer, Jessica Rosenkrantz, and artist, Anna Riddler. And I also know that we have people based all over the world participating, so please say hi and type where you're joining in from in the chat. It's always a beautiful thing to see where everybody is joining in from. And thanks a lot for being here. It's truly amazing to have you all here. And if I were to pick one perspective to AI that has been recurring in the first 4 couch lessons, it would be that of whether or not AI can be autonomous. And a way to philosophically, at least, measure that is to discuss this set of technology's capabilities of being creative. And luckily, that's the topic of today, and we have 3 experts with us to uncover it. And we will look into if a computer is able to creatively produce, how it's done, and what humans' role is and will be in all this going forward. And as with many other topics we're discussing in this series, they're not entirely new. And it's rather a continuation of a long history of thought and technological development. And in the case of computers and art, the history can be traced back to at least 60 years when artists like Vera Molnar was writing code that computers read and then produced works of art from. And when it comes to creativity, it's not only a question about computers' capability to produce content, it's also, of course, a question of our acceptance and the context it's being presented in. And if the wider system of audience, establishment, and in some cases also the market is ready to accept what's being created. So please keep this in mind when we're listening to the speakers today. By that, I think we're certainly ready to jump to the first speaker. And his name is Marcus de Sotoy, and he's the Simony Professor of Public Understanding of Science, and he's also Professor of Mathematics at the University of Oxford. And he's the author of 6 books, including The Creativity Code, that I highly recommend, that came out last year. And for us, it's going to give an overview of how AI is used to write, paint, and think. And please beam all your energy to Marcus. The microphone is yours.
Great. Well, it's wonderful to be with you. I'd just like to assure you that I am human, not an avatar that I've generated earlier that's talking to you. Although maybe you can try and judge that as we go on. Actually, I think it goes back a lot further than just 60 years because actually a young Ada Lovelace was taken along by her mother, who used to want to expose her to the big scientific ideas that were emerging during the Victorian age. And as a 17-year-old, she was taken to see the analytic engine created by Charles Babbage. This is a machine Babbage had made to do mathematical calculations. He thought that that was something a mathematician shouldn't waste their time doing, and so had built this wonderful machine to speed up doing calculations. But Ada Lovelace, when she saw this thing, realized it could do far more than just long division multiplication. And she started writing instructions, which we now regard as the first kind of example of computer code for making the machine pressing things. And we celebrate sort of computer coder, celebrate her Ada Lovelace Day every year in October. And during the notes that she wrote for what this machine might be able to do, she very intriguingly wrote, the engine might compose elaborate and scientific pieces of music of any degree of complexity or extent. So we already heard some AI music or AI collaborating with humans as you came into the meeting. So it's interesting she chose music because I think it's got a very close connection with mathematics and it's very abstract. And so in some ways, there's lots of algorithms at work when a composer sort of develops a piece. But she had a word of warning about the power of the machine. She said, it is desirable to guard against the possibilities of exaggerated ideas that might arise as to the powers of the analytic engine. It has no pretensions whatever to originate anything. It can do whatever we order it to perform. And I think that's very interesting because I think for many years, the feeling was that code was written by humans. It would tell a machine to do something. So anything that was created by a machine was ultimately the creativity of the human that had written that piece of code. And I think Ada Lovelace is probably right in respect to code written in this very top-down manner. But we've seen a real phase change in the last few years where code is being written in a very bottom-up manner. This idea of machine learning, deep learning, where the code is allowed to interact with data, and through that interaction, the code mutates, changes, reparameterizes itself, such that after this learning process, I think you're starting to see a divide between the code and the original human who wrote the original code from which it's learned. And so I think there was a real phase change that we saw, and there's a really fantastic example of something I would call a creative act by the code and not the original coder. And I think it's been talked about a lot in these meetings up till now, but just remind you of the story when AlphaGo played Lee Sedol at the ancient Chinese game of Go. Got quite used to code playing games at a very high level, but something rather extraordinary happened in the second game of that match. I watched these games obsessively on YouTube because I realized actually I'd always used the game of Go as my protective shield against why computers can't do maths, because I think playing Go, a lot of pattern recognition as the stones build up on the board, a lot of intuition, not quite sure why you're making moves, felt like a lot like mathematics. So I was very worried when I heard a piece of code might be able to play this game at a high level. And I remember watching this game. Lee Sedol had played move 36, went to smoked a fag up on the top of the hotel in Seoul. AlphaGo thought for a while and then asked the human player, interestingly, we still need humans to place the stones on the board because this bit of kit here is so wonderful. We haven't really been able to get a machine to do anything as wonderful as a hand. On the fifth row in from the edge. And I remember the gasp from the commentators. What a terrible move, because you never play that deep into the center of the board early on. Considered a very bad move. They were convinced Lee Sedol would win the game from that point on. He comes down shocked at this move because it's so bad. You know, your Go teacher slaps your wrists if you do such a move. But as the game went on, it turned out that this move was the key move that won AlphaGo that game. And so for me, what was so exciting about this move, it really passed three tests I'm looking for in something that I'm going to call creative. These three tests I learned from Margaret Bowden, a cognitive scientist who's been thinking a lot about creativity in the machine. She said it's got to be something new, something surprising, and something with value. So certainly a new sort of move. It was certainly surprising because I remember all the commentators gasping and saying, what a terrible move. And the wonderful thing about a game is that you can judge value very easily because it does it win or lose you the game. But I think for me, the most exciting thing was that if any human had seen that line of code play on the fifth row in from the edge this early on in the game, they would have deleted that line of code as a very bad instruction. So this line of code emerged from the learning process of the machine rather than from a human programming it in. So that was what really set me off on this kind of journey to write the creativity code, because I was very intrigued if it can be creative in this, you know, very tight realm of a game, where else can it be creative? And I think for me, the exciting thing is the role of code to help us as humans to be more creative, because what we've seen in the game of Go is that players have now learned to play this game in a completely new way. People thought they'd reached the peak of how to play this game, but the AI showed you an even higher peak, cleared the fog around us and showed a better way to do things. So for me, the best examples of creativity that I've seen in the arts are where a creative human has been pushed out of their comfort zone by code to be shown to do new ways to do things. So actually, Francois Pache, who was responsible for the album that we heard as we came in, he has this wonderful machine called the jazz continuator that learnt on the jazz riffs of a pianist, Bernard Lubat. And they played a concert together in a call and response mode. People had to judge who was playing, found it very difficult. But it was Bernard's response that I found most interesting, because he said, I recognize everything the machine is playing. It's my world, but it's doing things I never would have thought of doing. So for me, it was exciting to see this code pushing him into being creative in realms he'd never thought of. But the trouble is that music, and also the written word as well, has a temporal element to it, and after a while the music becomes very boring. This is where AI is having a lot of difficulty with actually sort of maintaining something which locally sounds interesting but globally starts to lose interest. For me, the most successful area has been in the visual realm, where we don't have this temporal element, and the most interesting story in the visual realm that I encountered on my journey actually gets to another kind of definition of what we should mean by creativity. It's one I ended up sort of migrating towards at the end of the book which is a definition by Carl Rogers, a psychologist, which says that creativity is our tool for sharing our internal worlds with others and understanding investigating our own internal worlds, really a tool for examining consciousness. And many artists have talked about the idea of our creativity as a tool for that. I would even speculate that our human creativity and our consciousness may have emerged at the same time. Now, for me, certainly code is not conscious yet, but the sophistication of code as it's learning and changing and mutating means it's becoming so complex, we really don't understand how it's making its decisions. And for me, the exciting thing is to find tools to kind of ask questions of the code about why you did this thing rather than that thing. And the most exciting example I saw was Google kind of examining how its vision recognition software saw the world. And it asked the code to kind of accentuate anything it was seeing in a kind of picture. And so this kind of, the art that it produced was very kitsch, but actually I think it was very interesting because it allowed us to see strange biases that were appearing in the learning of the code, strange things that it was seeing that we didn't realize were kind of there. And for me, I think one of the exciting uses of kind of creativity in AI will be as a tool to examine the internal workings of code, which are becoming so complex, we really don't understand quite how it's making its decisions.
Was that it, Marcus?
Yes, that's you gave me 10 minutes. So I think I'm just 15 seconds from 10 minutes. So there you go.
That's great. And I think that's a very good way for art and creativity to be useful in understanding AI going forward and sort of helping us see the glitches and helping us understand how the systems actually works. Thank you so much for that presentation or that introduction to the topics today. We will invite you back at the end for the Q&A. So everybody please ask questions in the chat and we will make sure to incorporate them in the discussion after the talks. Now to our second speaker. Her name is Jessica Rosenkrantz. She's an artist, designer, and programmer. She's the co-founder of Nervous System, a generative design studio that works in the intersection of science, art, and technology. Today, she's going to present some of her works and the process behind them. Please welcome Jessica Rosenkrantz. The screen and microphone is yours.
Hello. Let's see if I can share my screen. All right, hopefully you can all see my screen. Is that working? Excellent. Okay, so hi, I am Jessica, and as Martin just told you, I am one half of Nervous System. What is Nervous System? Nervous System is a strange mashup of design studio, research lab, artist duo, software consultancy, and lifestyle brand. And we work in many different materials and make a myriad of different products. We make jewelry, clothing, furniture, lamps, jigsaw puzzles, and even sometimes architecture. But what unites all of the things that we create is that it's generated by software that we write. And what we're really interested in as the studio is how computation can change the way we approach design. In our work, we explore creating new types of playful design experiences that leverage simulation and the web to make it possible for anyone to create. Cell Cycle is an app we created almost 10 years ago at this point, where you can customize cellular rings, bracelets, and art using a physics simulation in real time. These items can then be 3D printed in a variety of materials, from plastic to sterling silver. The intention here is that it's more like playing a video game than working with an engineering software. So rather than you having to worry about how you construct a certain piece of geometry, we let you focus on higher level design elements like density, shape, flow, fit, and you can create very complex objects that would be very challenging to model in a traditional way, either by 3D modeling or even physically making them. But instead, you're sort of engaging in it in a fun way, and you don't need to have any design experience to use this tool. This approach to design is very inspired by the complex forms that we see in nature. We're very interested in how these patterns emerge from underlying processes, including biological, physical, chemical, and geological systems. And I think it's really fascinating how you see very similar types of patterns across many diverse phenomena. We create generative software which takes inspiration from these process-based designs we see in nature, and we really focus on creating interactive processes that we as people can engage with. So instead of creating sort of a single static design, what we do is create dynamic systems. And our goal is that sort of instead of drawing structures, we're going to be growing them. So you might be wondering, what the heck does that mean? So here's a very concrete example. These are dendritic crystals. The left one is dendritic agate and the right is dendritic limestone. And these branching patterns were initially mistaken by scientists as maybe fossils of some long dead creatures, but they're actually totally just inorganic patterns that form naturally as water rich with iron trickles through cracks in stone. The branches can be described as growing through a process known as diffusion limited aggregation. The idea is that there's particles just moving around, which is what particles do. They're diffusing, they're moving randomly, and when these particles hit something, they stick to it. While this sounds incredibly simple, its repetition results in the emergence of fractal branching forms that can describe the formation of those crystals, but also certain forms of coral or various other structures like lightning. One of the appealing aspects of this system is that simplicity allows it to be encoded easily in software. So what you see on the right is what it looks like when I'm actually working. I have a code editor and I am typing out text and then running my code to generate the thing you see on the left. Once I've created a system like this, it's easy to generate sort of hundreds of designs, and I can start experimenting with parameters, making modifications to the algorithm, and start to introduce design constraints. I use tools like these to create products. These are stainless steel necklaces that are fabricated by photochemical etching. Every single one is one of a kind. So far I think I've sold probably over 5,000 of this particular series of necklace, and every single one is unique. Okay, so I'm going to quickly go through a couple of examples of how I use generative systems to create new opportunities in design. Kinematics is a project about making custom fit clothing using 3D printers. It started from a really simple idea I had about how to create a textile using a printer. These machines generally produce very hard, rigid plastic, but by interconnecting many small pieces with hinges, I can make a material that in aggregate moves and flows more like fabric. I found these sort of hybrid hard-soft creations to be really interesting, and I wanted to make something larger for them, like a dress. But the problem with the dress is it's much bigger than a 3D printer. So sort of took the idea that they're flexible and came up with a way to computationally compress the garments. So this is a simulation I created that I used to find a smaller configuration for these structures such that they can actually be printed in one piece. If you can sort of print them all in one piece, that means you're able to create a garment where nothing ever has to be cut, sewn, or assembled. It emerges from the machine fully formed. So then The challenge is, how do you design these garments? I wanted to create a tool that sort of anyone could use to playfully design garments in 3D. The system works directly on scans of people's own body, and then it's a web application where you can playfully and interactively design these garments. The resulting dresses are these sort of intricately patterned structures with thousands of interconnected pieces that are all 3D printed in one piece and emerge from the machine ready to wear. The project for me is an example of how I foresee generative systems enabling people's creativity and opening up the design process and manufacturing to more people to engage in. The second project I'm going to talk about is called Hyphy, and it's about using generative design to understand nature and also to create natural systems themselves. It started really just from a love of leaves. Leaves are beautiful, and I'm completely fascinated by all of the intricate branching patterns that we see in leaves, which are different between every species and indeed within every single leaf. There are many competing theories that scientists have on why these actually form, but the theory that I found most interesting is called auxin flux canalization. It's a mouthful. It is basically a chemical signaling process where there's a growth hormone that's being produced all throughout a leaf and sort of diffusing throughout it. And there's kind of positive feedback mechanism where it flowed before, it's more likely to flow in the future, sort of like water progressively digging a trench. We started working on building a computational model of this process as described in a paper by Adam Runyons. Once we built the model, we started playing with different parameter spaces and looking at what sort of patterns are possible and also what sort of leaves those are like in nature. But we also start to look at sort of impossible situations that would never occur in real life, like this one labeled multi-root is a leaf with many stems, which is not a thing that actually happens. Or playing with how varying density can make sort of typographical messages appear in the venation field. We use the system to create our Hyphy lamps, which are 3D printed lampshades which cast these intricate shadows, sort of like leaves on a tree. Every single lamp we make is unique. Our intention in studying these sort of natural systems isn't to directly copy nature, but instead to learn sort of how the systems work and adapt their logic for design. So leaves are flat, but we said, why don't we try the system in 3D and see where that takes us? And we ended up creating these sort of more complex sculptures, but we didn't really have a function for any of these, so we sort of printed a few of them as art pieces and left it at that. But a couple of years ago, we got an email from this guy. His name is Jordan Miller, and he's a bioengineer at Rice University. He's developed a new 3D printing technique for living cells. The goal of his lab is to design replacement organs. So globally, there's a shortage of organs for transplants. And in the future, his vision is that we could 3D print organs from people's own cells, which would avoid rejection. Tissue printing, however, is still in very early stages, and the biggest challenge is just keeping things you print alive. It turns out you need blood vessels. Blood vessels bring oxygen and nutrients while removing waste. And he looked at these 3D branching structures we'd been generating and thought these would make pretty good blood vessels. And he challenged us to sort of collaborate with him on designing lung-like structures. Lungs, as I'm sure you're aware, are really complicated. They have multiple intertwining networks of fluids, such as air and blood. And we sort of worked on developing the smallest unit of the lung. So this is our generative design for a lung alveoli, which is shown with human red blood cells being oxygenated. So we designed sort of a central bulbous chamber and then this sort of directional cellular branching field around it to carry the blood. Our goal in creating software like this is to create tools that are going to enable scientists and bioengineers to create customized multivascular structures for 3D printed organs. And this is sort of one of the versions of software that we've been working with him on generating these different intertwining air and blood vessel networks. I think this project is a really weird turn of events because we were essentially inspired by the circulatory systems of plants. We made lamps, and then it came sort of full circle, and now we're working on making actual living replacement organs for human beings. And I believe that is my 10 minutes, so thank you for listening to my crazy story here.
Thank you very much, Jessica. It's very inspiring to see what you've been achieving in the lab. Look forward to follow that going forward. And also keep the conversation going in the chat. There's some really good questions coming through. We will make sure to bring in as many of them in the Q&A after our third speaker. And that is Anna Riddler. Anna is an artist and researcher who works with information and data for us. She's going to talk about why and how she's using machine learning tools in her artistic practice, and in so doing, showcasing one of her projects. Please welcome Anna Riddler. The screen and microphone is yours.
Thank you. As Martin said, I'm going to talk a little bit about what this means coming from an artistic perspective, in particular kind of thinking about how using AI is influencing my practice and what it means for something to be considered art rather than just being considered kind of something that might be produced from a machine or an algorithm. Oh, let me actually just, before I do this, it is view into full screen. There, that's better. Is it full screen for everyone? Yes. So I work a lot with something called a GAN, a generative adversarial network. I'm primarily a visual artist, and that's something that I'm really interested in. When you work with machine learning, there are kind of two main materials in my mind that you're working with. You're working with the algorithm, and you're also working with the data or the training set. And that's something that I'm going to come back to a lot in this talk. I work with GANs, as I said. This is then a form of unsupervised machine learning, which are notoriously unstable. They were invented in 2014, which is basically ancient in machine learning terms. And then unstable and not that well understood. Kind of how they actually work, their internal mechanics isn't that well understood by scientists. It's kind of this complex iterative process of these two intelligences dancing around each other to produce the kind of images that you're seeing on the screen at the moment. You kind of have these two networks. One is trained on a series of images, the data set, the training set, which it then uses to try and create a realistic version of the image that could potentially come from it. The other network is trying to guess whether that image is true or false, real or fake. And they kind of go through these many, many cycles called epochs to try and get to a point where one network is able to convince the other network that the image could be from, in this case, the category in question. This video that is playing at the moment is from a science experiment, but I really, really love it because if you look at the images, they have this kind of meandering, dreamlike quality to them, and they're not kind of it's not taking photographs and kind of taking individual elements and stitching them together. It's the kind of the algorithm constructing the image from the very ground up, kind of to kind of make something that it thinks that it should be producing for the category in question. They kind of like the results kind of like, and this I should say is a couple of years old, the results are kind of recognizable as real, but definitely at the same time not real. And there are these imperfections to the images, the traces of the process, which is this quality that I absolutely love about working with machine learning and that I want to question and work with. But it's also a quality that will exist for a finite amount of time. If the technology industry wants realism, and so you're kind of getting this drive by researchers, by industry to produce kind of like images that look more and more and more realistic. You know, all the deep fakes that you see all the time on the internet. And as someone who is using this as a creative person, I really like the mistakes that this video is showing, these imperfections, as not because it produces something beautiful, which it does, but also because it draws attention to the process of machine learning, and also potentially what is wrong with this process. Because as soon as something becomes too smooth and too perfect, it stops being noticeable. And when it stops being noticeable, people stop questioning or challenging it. So how have I used that in my own practice? So playing now is a very short kind of video snippet of a piece that I made last year. I try and use machine learning, as I said before, not just as a tool, not just something that can make something, but as a process. So it's something that kind of impacts how I practice across kind of many, many months. I also try and use it only when it kind of makes sense for the project. So never just because it's like the cool hip thing to do, but because fundamentally it's echoing stuff that I want to talk about in the piece anyway. So this piece is called Mosaic Virus, which draws on historical parallels about tulip mania that swept across the Netherlands and Europe in the 1630s to speculation that is going on at the moment around, or was going on at the time that I made it, around cryptocurrencies. So in this piece, each of the stills is generated using machine learning, but the appearance of the tulip is controlled by the price of Bitcoin. Mosaic was the name of the virus that causes the stripes in the petals, which increase their desirability during this kind of mania in the 1630s. And in the piece, as the tulip becomes more and more stripy, that's the price of Bitcoin going up and up and up. And I wanted to draw together ideas around capitalism, value, and the tangible and intangible nature of speculation, and collapse from these two very kind of different but similar-ish moments in history. I am not the first person to kind of make the connection between Bitcoin and tulip mania. The Dutch central bank did it back in 2013, but it was something that I kind of wanted to draw into this piece and kind of see the way that it echoes the prices of tulips going up and up and up to the price of Bitcoin going up and up and up. But why I chose to then kind of use it with AI, one of the reasons was because AI is in the middle of its own speculative bubble at the moment. So these were kind of quotes that were from the headlines when I was kind of making and researching this piece. And so the AI as the kind of way of working, the material, is also echoing kind of the things that I'm talking about, these booms and busts. Everyone is kind of talking about how questioning when the next AI winter is going to happen, when the next collapse will come, because there's so much hype, so much money going into it at the moment. I saw on a billboard near me that there is an advert for an AI-powered toothbrush, which just shows that it's kind of really becoming so kind of like hyped up at the moment. Another really important thing about making this piece, as I kind of talked about at the beginning, was I'm really interested in working with the data and the training set to make, because when you're kind of like working with this stuff, a lot of the time it's just kind of data is just kind of scraped from the internet and kind of like put into these categories, often by mechanical Turks who don't kind of necessarily are expert in the kind of area, and you get a lot of what is called dataset bias, where things are mislabeled, or you kind of get kind of racism or sexism kind of embedded in the way that these datasets are constructed. So for me, it's always really important to make every part of the project myself, kind of doing all the coding and then also doing all of the dataset collection. To make the tulips, I took 10,000 photographs of tulips. I was based in the Netherlands, so it was actually affordable. And it kind of really inverts the usual process, as I said, of making these kinds of things. There's something very different about doing the work yourself versus kind of like scraping the internet. And you kind of, it becomes like craft, very repetitive, very kind of manual, often kind of like unauthored, but essential to kind of create something beautiful. And then the other thing that I had to do to make this piece was then categorize every single tulip myself, because in order for the to be able to control roughly what type of thing was being made by the algorithm, it had to kind of have this information. It doesn't know what tulip is. It doesn't know what color a tulip is. I have to give it that information myself. And so I decided, because this was such a large amount of work, to make it into a separate piece. And for me, it's really important to bring this human quality out of machine learning in the art, because, you know, it's very easy to consider them digital images, but somewhere kind of very far back along the chain, it was a real object in the real world that someone had to photograph, someone had to label, before it then kind of becomes part of this kind of abstraction into code, into kind of like an algorithm, and then kind of into an image that comes out at the end of it. And I'm really interested in bringing this very human quality out of it. And you can start to have discussions as well through work like this. So the entire data set is 150 square meters when it's installed altogether. And people have a very different reaction to understanding what 10,000 images are when they're spread over across that scale than if it's just on a thumb drive that you can scroll through. And people can examine the labels that are given to it, because it's not absolutely correct whether something is red or orange or yellow or white. And if it becomes difficult to do that for something as simple as a single type of flower, it really starts to get people questioning about, you know, how can this be done for complex issues and complex ideas. And just to very quickly conclude, because I know that is probably my 10 minutes are up, this whole process of creating the data set took months and months and months. It took me an incredibly long time and was incredibly time consuming and difficult work. And I spent ages categorizing them and thinking that I was correct and kind of labeling everything. But despite all of this categorization, it was absolutely a mistake to think that I would know what would come out of the model, that I would know what type of tulips would be produced at the end of it. I can guess, but I will never be able to know. And for me, that is what makes it so exciting, that you have to have these two separate kind of like mindsets together in your head at once. The kind of like absolute concentration on kind of like the type of person who will very happily categorize loads and loads and loads of photos and be very meticulous about things, and also be the type of person who can be like totally free and open to whatever comes out. And that is why I find it so exciting and interesting to work with.
Thank you very much, Anna, and thank you all three of you for great presentations and some really interesting thoughts in introducing what AI and creativity is. And it's clear that there is an interesting sort of way from human to computers, and there's this big intersection in between where it's humans and computers working together. And I think there are some questions about that as well from the participants. I'm now going to hand over to Jeanette, who has sourced some great questions from the chat that we will now hear.
Exactly. So I hope you can unmute yourself now. And I would like to start with a question from, I hope I pronounce it right, Vishal Kumaraswamy. Maybe you can speak up.
Hey, yeah. Can you hear me?
Yes.
Okay. So my question was for Marcus, particularly as I'm kind of interested in some of the things that you were talking about. The question I was asking was, can we consider creativity to be a conscious decision to step out of logic for an AI? Particularly because I'm interested in how the AI substantiates its decision making, and if this sort of stepping out can be considered creativity, and if it is considered creativity, can we then think about it in terms of autonomy?
So many interesting things in that question. I think there's one word that came up for me, which was really important in kind of distinguishing what's going on here, which was the word intention, because humans have an intention to create something, and for many different reasons, very often about expressing a way that they see the world. And at the moment, that for me massively distinguishes the creativity of a machine, although the machine might produce something that is genuinely coming out of the code in the learning process and will surprise us. As Anna said, you can't predict at all really what's often going to come out of that learning process, but still the intention for me is coming from Anna or whoever, or the AlphaGo team who set AlphaGo playing Lisa Doll, and the code doesn't want to do anything. So and I think that is related to consciousness, that consciousness allows us to have maybe an illusion, but that feeling of free will, that we act to create something, to express something. There's an interesting expression used there as well about sort of stepping outside, and I think that's one thing that really some people feel will distinguish humans and AI, that the AI has to work within a system very often, whilst our best creative moves are when we break the system and step out of it. But but I think, and I talk actually in the book about 3 different sorts of creativity. Again, something I learned from Margaret Bowden. Exploratory creativity, working to the extremes of a system to see what interesting things might be still within the rule set. Combinational creativity, where you bring a fusion of kind of one style to another, which is, I do use that a lot in my mathematics, learning from somewhere else, some way of thinking, and I'll bring that to the thing that I'm particularly interested in. And then transformational creativity, which is the sort of something from nothing, but something always never appears from nothing. There's always a kind of rationale, I think, even for these phase change moments in art. And actually, if one examines, how do you do a transformational moment for a human? For me, it's, where does the square root of -1, imaginary numbers, come from? It comes from breaking a rule, which is that all numbers should have squares that are positive. But I think you can have a meta piece of code which challenges that system and breaks things, and see, most of the time when I break something in mathematics, it collapses a system, and it's not interesting. But there'll be a few moments where I'll break something and really something extraordinarily new emerges, which enriches the environment. And I think that is something that we can actually capture in code. I think part of this is understanding our own creativity by trying to sort of, it's after all what Turing was after with the idea of AI, was to understand our own intelligence by trying to simulate it. It's helpful to challenge our own creativity to sort of see, well, how would you actually write code for that? But ultimately, the most interesting thing is when it's doing something completely different to our own creativity, and we get this fusion, this collaboration, where it's doing something that we would never have thought of, and that collaboration together as a tool, and I think it's a tool rather than anything more at the moment. Exactly, I would agree with Anna about the hype. I think we have to be very careful about the hype of AI, because I think my toothpaste is created by AI. I'll have to get one of those toothbrushes to add to it.
That was great, thank you.
And I have another question for Anna from Yasha Jane. Can you speak up?
Hello, can you hear me?
Hi, yes.
Hi. I wanted to ask Anna, what other implementations of GAN does she think could be there apart from creating interesting images, because that's generally the landscape that it has been working in. All the showcases for GAN have been just creating interesting images. So if you could tell more about how else it could be used.
So I use it primarily because I am interested in like the kind of how it can be used in a creative way. And I know that there haven't been that many commercial applications of it, because it still is kind of very unpredictable in kind of what it will generate. You get these things called artifacts, where the kind of blobs and the kind of the weirdness, even on very, very well trained ones, they will look almost exactly real, but then when you look at them precisely, there are these tells. So even if you're looking at kind of like the latest deepfakes, there are these small things that kind of like will give it away. So I know there is research into using them in kind of medical imaging, for example, as a kind of real world kind of like way of using them. But there's also a lot of nervousness about using them, because if you're using them in kind of medical research to generate data sets, for example, you really want them to be precise, and kind of having these kind of like things that kind of like are weird and kind of aren't there is something that kind of like limits maybe their usefulness for real world applications at the moment. So that's kind of like, I don't think there's that many kind of real world applications of them at the moment.
Okay, thank you.
And then I have a question from Liane Heidenreich about the limitation of the human coding. Maybe you want to speak up.
Hi, can you hear me? Yes, my question was in connection with Marcus' talk about how he described a machine that was playing a game and did something surprising. And I was wondering if that really shows creativity, or if it's not just showing how limited we humans are, that we cannot imagine such moves. So in a way, still confirming Ada Lovelace that, you know, the machine just does what we tell the machine, and then if the machine spits something out that we have never seen before or that we didn't think of, is not really creative. It's just that we as humans are not intelligent enough or too dumb to have it imagined before, instead of the machine really being creative.
Yes, I think you know, it's interesting because it's a good example of kind of exploratory creativity, because you know, you are working within that rule set, and in some sense we haven't explored the limits of that rule set. But I do think, you know, it's a very good example, absolutely what you say, that humans, and especially creatives, we tend to get very stuck in particular ways of thinking. I think actually we end up almost behaving more like machines after a while, because we repeat the particular things that we found are successful in creating something. And that's why I think this is a very powerful tool to kind of kick us out of our routines and offer something new. So I do think, you know, just because it's a game or because it has rules, I don't think that means that by its nature, it doesn't mean that this thing is being creative. I mean, within that definition that Margaret Bowden gives of something surprising and having value, I think that's why games are very nice places to kind of judge that thing. But I think, you know, when you move to the music example, where Bernard Lubat, again, it's a sort of world that he works in, the jazz riffs and everything like that, and the machine learns his particular style, the different decision-making processes that he's going through, but then offers within that world, a bit like the game of Go, hey, but what about this? You haven't, I've never heard you play this, and this is certainly consistent with the whole kind of rules of the game. And you know, Bernard Lubat said, you know, that is, you know, it's playing things that I could have played, but it would have taken me years to actually develop. So for me, that's exciting when we can use this as a tool, even within a kind of confines of where we are at the moment, to realize there's still possibilities there. But I think why, you know, the GANs, I think, are one of the most exciting areas, because that's pushing us out of, you know, it's sort of making something kind of, which isn't just a repeat or a different version of what we've seen before. It's really creating something new by this kind of game that's being played by the discriminator and the creator algorithms. And I think, you know, talking to a lot of artists, people often say it takes two sides to create anything, you know, the creator side of your brain and the discriminator. And certainly in mathematics, I use a lot of collaborators in that way to play a role when we're in the room together, of one being very sort of one algorithm side and the other being the discriminator. So I think for me, and I like that challenge that was offered by one of our participants about, well, yeah, why not GANs in music? Why don't we get a GAN? And I'm not, maybe there are examples and perhaps people can put them in the chat if they know them, but I think a GAN in music would be really interesting to learn on styles of music up to this point, but then offer the challenge of something which breaks those styles, but still can be regarded as music and not noise, would really be a fascinating use of this technology.
And just to kind of follow up on Marcus's point about, I kind of like the way that I most commonly describe kind of like the sensation of kind of like seeing what comes out of a GAN the first time. It's like catching a glimpse of yourself in the mirror before you realize it's you, when you kind of like, it's familiar, but it's not familiar. And you get that uncanny sensation of kind of seeing stuff that you've done, and it's definitely work that you've made, but also kind of just that it's not you at the same time. And it's that's the closest that I can come to describing kind of like the feeling of kind of seeing something that comes out.
So thank you. And there have been a lot of comments from Jutta Marta Beiner. So maybe you want to speak up as well. Do you have a question for the three speakers? No, maybe not. Then I go on to Luciana de Castro, and she is asking if there is any art beyond being kitsch, but maybe you want to speak up also. Luciana? We can't hear you.
Hello?
Yeah, now.
No, I just wanted to say that actually I think my question was already answered. I was rather thinking about how AI can be active on complex and abstract creation of concepts and that are maybe unpredictable at all. And I think that was already answered. Thank you.
Thank you. And there was also a very long comment from Debashi Sinya about the interesting point when the data set and the modeling breaks. Maybe you want to speak up also.
Yes, hello. Greetings from Canada. I guess what's interesting to me is because I work with sound, and I've only just started exploring these tools, what I'm really coming up against is what a lot of people have been talking about. I mean, Anna Riddler talked a little bit about creating a data set that took forever. And this this idea of data sets, and I mean, the algorithms are one thing, but to me, the data sets are kind of the currency of AI and machine learning. And I know there are many open source data sets out there, but as a person of color, what's interesting to me is the illustration of how the data is a reflection of who we are and how our society's been built. And so when I think about that, and I'm working with sound, what's interesting to me is how to expose that in a way. I guess that's just one of the things that I'm interested in exploring in my art. So, you know, a code like style transfer, for example, that, you know, can take one source and impose it onto another. So what happens when, what happens when a model that's trained on a jazz quartet is fed audio from a Cambodian gamelan? You know, those kinds of things I think are very interesting. And to me, at least for me at this point in time, it's not so interesting to replicate human impulse and then to see what the models come up with that we don't expect. Like the piano player was like, oh, I know what this is, but all this stuff is happening that's very interesting. I wouldn't have done it. I think we can go even further, and that's at least for me, that's very interesting to really push, instead of trying to emulate a jazz quartet, to pull apart audio that I feed it to expose the worldviews that we are working with when we work with these tools. And how can we make that worldview more inclusive or broader or more nimble? And I think often a success, at least for music, success using these tools is illustrated by replicating a model. But the model itself, or the data set that the model is trained on, is inherently biased. And so how can we expand the bias, I guess, or expand the worldview that these tools are exposed to? Because that's us. We're exposing the tools. The tools don't know anything. We're telling the people, we're telling the tools what the world is. How do we make that world, how do we tell the tools that the world is bigger? How do we develop them?
Yeah, could I just say a point on that, because I think it's really interesting. I did a project at the Barbican last year where we trained machine learning on the music of Bach, and then we did an experiment where we made a hybrid piece, which was a Bach's English suite with pieces taken out, and then we filled in the gaps. The AI had to fill in the gaps, and how well did it do? It was kind of an interesting exercise. But the point I want to make is that the harpsichord player who played the piece said, you know why these are called the English suite and not the French suite or the Italian concerto? Is because Bach loved the cadences of language, and that we'd missed this data set to feed into the learning process. And I think at the moment we're so obsessed with data sets which are specific to the actual output, visuals for visuals, music for music, written word for written word, that we're actually missing that, of course, as humans, we have an extremely rich and complex and diverse data set. And for Bach, the English language was informing the compositional process in when he wrote those English suites. So I think that's interesting, and also a challenge for us to see. You know, you talked about style transfer, but across musical genres. But what about style transfer from visual to music? I mean, there are already lots of examples of that as an artistic practice. Xenakis, for example, was very interested in the idea of visual. The relationship between visual and music, but I think you know, it was one of the restrictions at the moment. Why AI, for example, is so bad at writing is that it doesn't have all the context that we have of history, sociology, so many things which inform how we use language. That's why it fails on things like the Winograd challenges, because it can't say what a word refers to, because we're bringing so much more into it. So I think that kind of the role of rich data sets going forward is going to be really interesting.
Yeah, and just I think data sets can be an incredibly important part of an artistic practice. For me, they're like one of the key things that I consider myself to make when I'm doing a piece. It's not just like a video work, it's not just a sound piece or whatever, it's the data set. And it gets presented in a gallery as such. And up until very recently, British copyright law considered a database, they gave it the same level of protection as a literary work, because they recognize the amount of labor, the amount of time, the amount of effort, the huge amount of kind of work goes into constructing something like this, which I really, really like. And I think, yeah, I think there's, I could talk for the whole hour about data sets. And, you know, you mentioned whether, you know, you can ever have it about things like bias and the ethics behind it, because, you know, it is a very laborious process, and this is often erased, and it is kind of very, you know, the ones that get used time and time again in scientific experiments and for kind of research and then for industry tend to be very privileging kind of Western ideals of what things are. And so there are all sorts of questions about whether I personally don't think you can ever have an unbiased data set. It's one of the reasons why I construct my own, because then at least I'm replicating my own biases, if you will, rather than someone else's. But I do think you can have an ethical data set. So when you have people who are paid a fair wage to label things, when you have kind of better working conditions, when you have kind of like more control over kind of the type of stuff that ends up in it. And that's kind of like a separate question and debate, but yeah.
Thank you.
And there's another question from Vero T. Maybe you can speak up if you are still joining us. But maybe it's still an interesting question, because it is it desirable for AI to be creative at all? Any comments to this question?
I think it is very desirable in the sense that because we're beginning to develop code that we don't fully understand how it's making its decisions. So that idea of you finding tools to probe the decision-making process of the code, the biases that are in the code. So for me, that goes to the definition I mentioned of Carl Rogers as creativity as our tool for examining our own inner worlds, sharing, trying to solve the hard problem of consciousness. So I think it's desirable in that sense. I think it's desirable also just as a tool for perhaps as a collaborator and helping us, like the moment that the camera appeared on the scene. That was an incredibly exciting moment and it meant that human creativity changed and shifted. So I think I'm not saying that the camera is creative, so maybe still we shouldn't be calling the AI creative, but I think it's a fantastic new tool to put into the kind of mix of exploring our own creativity.
So I think we have time for one or two more questions. Whenever something is coming up for you, for the audience, please just unmute your phone and ask. Any questions from the audience?
I had one.
Okay.
Big question.
Hi. I just wanted to. Sorry.
My name is Alicia from Spain. Do we really know how our mind works so that we can artificially reproduce it? Thank you very much.
Well, it's interesting because I actually have started to try and translate AI not as artificial intelligence, which is what Turing sort of wanted to use this as a tool to examine our own intelligence. But actually, I rather like AI as augmented intelligence, that, we should forget about trying to really replicate what we do. We know how to make our intelligence. We do it in the bedroom rather than in the lab. And so I think much more interesting to create something which is going in a different direction to ours. So I quite like translating AI as augmented intelligence rather than artificial intelligence.
And I think there's a last question from Yasha again. Maybe you can speak up.
Hello. Hi. I wanted to ask Marcus on what he just mentioned, that you see it as a tool rather than the big hype that it is as AI, just as how camera revolutionized things. Could you tell more about how it is different from the usual advances in technology that we have seen that augmented our lives? Or is this also in a similar vein as, say, cinema or other tools? Thank you.
I think one of the big differences is how it's enabling us to navigate data at a different scale to our previous tools. So for me, it feels a little bit like a telescope into the digital world. So it can navigate. For example, I went to a humanities conference and they were using it as a tool to look at the whole of 19th century novels, literature, many novels that had never been read for 100 years. And so I think there's something quite exciting about having a tool to look at data at this kind of scale. But what's very interesting for me is that actually this scale question is also beginning to distinguish the creativity that's coming out of machines from human creativity, because a lot of the things that are coming out of GANs are starting to have a complexity about them that the human sensory system is finding difficult to navigate, that they're almost too complex and busy. It doesn't have, a very good example was in the piano piece that we developed. The pianist also said, I know when it goes into AI because I can't play it. It isn't embodied. It becomes incredibly difficult to sit under the fingers, whilst Bach wrote things that were to be embodied. And so this kind of relationship to time, for example, it's able to create things temporally it can navigate whilst we can't. My favorite AI movie is Her, which is a guy who splits up with his girlfriend and then has a relationship with an AI girlfriend. But halfway through the film, the AI dumps the human and says, "You humans are all far too slow. You know, interacting with you is just not fun. I much more enjoy interacting with another AI where we can know each other in, you know, just a few seconds and interact at a speed that humans, you know, we're having to put words together very slowly." And I sort of feel like AI is going to start to look at humans in the same way that we humans look at like mountains. We don't think mountains have a life to them, but actually, of course, over deep time, yes, they do. They grow, they go down, they're very dynamic. So I wonder whether actually there's going to be this kind of divide where the AI goes off and does things which it's going to share and enjoy, but we're just not going to be able to like actually keep up with the kind of difference of scale that's happening.
That sounds like a very large interconnected AI that then wants to just talk to itself and not to us anymore. Yeah. Can't blame it.
But I think actually the most exciting thing is to have this as, you know what, I think we need to develop empathetic AI, and that's why having AI that's training on so one of the interesting stories that I told in the book was an AI which learns on our storytelling, and when it was asked to tell its own story, choose a kind of tree of possible stories to tell, it chose a much more empathetic, humane narrative because of its learning process on our stories. Now, you could say, well, actually, we're sometimes very bad at leading, you know, perhaps AI should be left to develop its own morality and its own, you know, we shouldn't use our biases. But if we want an AI to understand us, then it learning on our storytelling might actually help to create something which is an empathetic AI and doesn't go off on its own and wipe us out.
Right. Thank you.
So Martin, I hand over to you.
Yeah, I just want to say again, thank you very much to the speakers and also for the great conversation that's been going both in the chat and in the Q&A. It's all recorded, so if there's anything that you've missed, we will publish this talks on YouTube. And I also thought it was a very interesting bridge to our session next week, which is going to be on AI and ethics, and specifically talking about sort of the intentions of the programmer and intention of the artist. I think that's a good theme to bring up in the ethics conversation next week. And also we will have a conversation on AI and bias in 2 or 3 weeks, I think, where a lot of these threads could be brought in as well. So thanks a lot for your presentations today, and please join us in the coming weeks as well. Jeanette.
Yeah, thank you all for listening, and yeah, spread the word and maybe make some advertising through your social media channels, and we are happy if we can see you again next Wednesday. Thank you very much.